Good morning, everyone, and welcome to the FortiGate Info-Byte titled Remote Access Simplified and Secured. My name is Adriana Angeleska, and I am the Event and Communication Specialist here at Wavelink. Today, your webinar will be hosted by Kieran O'Brien, which is Wavelink's Fortinet Enablement Lead. Kieran is Wavelink's enablement lead with more than 5 years of experience in the IT industry and technical sales. Kieran is ICAO certified and is building his Wi-Fi expertise while developing his specialty in the SMB market and secure brand solution. Joining Kieran today will be our Wavelink Fortinet pre-sales engineer, Brendon Schodel. Brendon has spent the last 8 years in the industry focusing on integration with Fortinet and other technologies. He has a proven track record delivering high-end solutions from data centers to SMBs, and his focus is to connect with and empower Fortinet partners by mentoring and delivering enablement and training, as well as assisting Wavelink partners to be the best version of themselves in a competitive market. Today's webinar is part 1 of a series of 3, where we will delve into Fortinet's Zero Trust Network access offerings and how to integrate them into your organization. Part 1 today delves into how Fortinet's Zero Trust Network access, or ZTNA solution, can help organizations meet today's heightened security requirements while providing seamless access to infrastructure without the need for manually creating and establishing VPNs. Just one quick note, if you have any questions during the webinar, please share them in the chat box or the questions box, and we will strive to answer them at the end. I will now hand over to Kieran to begin the webinar.
Thanks, Adriana. Good morning, everyone. Hopefully we're all doing well. As Adriana introduced us, I'm Kieran. We've got Brendon with me helping to do our webinar for today. So at a high level, we're going to be going over what the current and evolving threat landscape looks like for traditional VPNs and remote teleworkers. We'll give an overview on Fortinet's ZTNA solution and have a look at the 3 main components. We'll then do a little bit further dive into exactly how the actual ZTNA solution works for remote teleworkers. We'll have a look at some of the key features of the ZTNA solution, which is really quite interesting. Some really cool new developments around the Zero Trust network offering since we last spoke about it. And then we'll go and discuss where to find further details and what are the ordering options, licenses, and SKUs that you would need to develop a solution for ZTNA. If at any time you have any questions, please feel free to shoot through a question in the question section and go to webinar. Otherwise, there's a chat feature as well if you need to. We will be doing a Q&A towards the end, so if you wanted to hold your question till then, you're welcome to. Otherwise, at any time, please feel free to shoot through your question. Just before we jump in, just want to take a couple minutes to introduce Wavelink, just in case you haven't dealt with us before, because there's a few names on here that I haven't recognized before. So welcome, everyone. We are a product intimate distributor. We're quite focused and we're narrow vendor in terms of our portfolio. And we do this to support our solutions that we put out to markets and to support our partners. We're trying to be as product focused and build our depth of knowledge to help you guys. Additional ways we support our partners is through a range of specialized marketing campaigns and services that we have on offer to our partners, as well as our sort of revamped professional services program that includes staging, rollout, and installation services. And we'll have more details on some new services that we're rolling out, hopefully for you guys pretty soon, to help you guys sort of get out to market with some of the solutions. Now let's jump in and have a look at the current remote access threat landscape. The 3 key major drawbacks for traditional VPNs for businesses and enterprises are the perimeter-based access approach that is most commonly used with traditional VPNs. There's limited insight into content traversing through these traditional VPNs typically, and also the way they're designed really limits their scalability. So having a look at the perimeter-based access approach, with traditional VPNs, users connect through the VPN client to a VPN gateway, and this is done to establish a secure connection from their device to the corporate network. This is what's known as the perimeter-based access approach. Then once that employee establishes the VPN, they are connected to the inside of the perimeter and often have broad access to the network. And this is sort of done due to the complexity of having to list and upkeep that list of access policies for each and every single server and infrastructure device that the customer has within their network. Now, this broad access approach exposes both the client and the internal infrastructure to threats. Every time a device or user is automatically trusted in this way through this traditional VPN approach, it places the organization's data, applications, and intellectual property at risk. Most businesses are choosing to use a split tunnel VPN type to allow general internet traffic and public cloud services to go directly from the client device to their intended service via their own internet link, instead of sending all that traffic back to the company's VPN gateway or the perimeter firewall. Now, this is great to reduce the amount of non-business network traffic from clogging up precious network connectivity and bandwidth and resources, but because most remote teleworkers are connected to largely unsecured home networks, they often become a primary target for cyber criminals who are looking for an easy exploitable point of access into the network. Because they're not sequestered behind an enterprise-grade security solution, they become easier targets for things such as social engineering and malware. And VPNs can become conduits for malware to return to the corporate network, as if an end client becomes infected, this could provide access to the corporate network via the VPN the next time the client is connected back through the VPN. And this is completely unbeknown to that remote user, that remote staff. And this potentially gives direct access to the corporate infrastructure from attackers. Also, in terms of scalability, critical resources and applications for businesses are now spread across multiple data centers and multi-cloud environments. And most VPN solutions weren't designed to manage this level of complexity and require all traffic to be funneled through a single VPN gateway. Now, a single VPN gateway effectively forces all of your connection backhauling to go through a central concentrator for inspection and distribution, which is quite resource intensive and potentially lag inducing if the servers are spread across multiple different geolocations and data centers. What this all means is that special consideration needs to be made for network designs, pipeline capacity, and inspection throughput when companies look to increase their resources, application, or staff count when they're using a traditional VPN approach. And ZTNA is sort of brought in to try and alleviate this, and we'll see how that sort of works a little bit further down in the slides. Now, this is a big issue given that we are now working in an ever increasingly hybrid work environment, and more employees are wanting businesses to be able to be flexible with their working locations. And data has shown that while COVID has certainly made a massive increase in the amount of people working from home or alternate locations from their designated corporate office, where there already was a trend of employees increasingly taking up working from home on a regular basis prior to COVID. And there continues to be an ever increasing demand now that we've sort of seen the bulk of COVID sort of done, and we're getting back to a level of normality. Now, traditional VPNs, while they do make it possible for companies to expand and allow for a level of flexibility, as we said before, it does bring many issues such as access and security issues, as well as scalability issues. So to help businesses alleviate this, Fortinet has a very diverse and comprehensive solution called Zero Trust Network Access. And this aims to help companies overcome the access and security issues of traditional VPNs while being massively more scalable. Now, Zero Trust Network Access at a very high level provides a better remote access solution than VPN, while also providing a layer of protection for your internal and cloud-based applications. And this leverages FortiOS on FortiGate and FortiClient. ZTNA provides granular control to applications no matter where the user or that application exists, with automatic encrypted tunnels and device posture checks to make sure that you're meeting your required security level. Now, ZTNA solves the issues of traditional VPNs by applying zero trust principles to control users' access and rights to applications, all while providing direct connections to applications across data centers and the cloud when needed. And it does this through things called proxies and brokers. And we'll see when Brendon speaks, he'll give a little bit more information about exactly what a proxy and a broker is. Now, what this does is it creates a much smoother user experience for the user and reduces your reliance on a single VPN terminal point to distribute VPN connections. For those of you who are wondering what zero trust principles are, zero trust essentially abolishes the idea of a trusted network inside a defined corporate perimeter. And ZTA, or zero trust access, mandates that enterprises create things called micro perimeters of control around their sensitive data assets. And this is done to gain visibility into how the user is using that data and how they're accessing it. And the idea is to essentially allow for a heightened level of security within their ecosystem. Now, the ZTNA is a security strategy and it has three core principles. The first of which is to never trust and always verify. This is not only where first-time authentication happens, but continual verification authentication for every session. So each time a user tries to initiate a new session, the solution will go through and re-verify that user, make sure that they're still meeting their requirements. And if it does, then it will allow that session to go through. If not, then it will actually disallow all the current sessions. Minimal access. This provides users with only the required privileges to perform their jobs. So for example, if you had someone in accounts and you had someone in sales, then you want to limit their access to only solutions and applications that provide use to them for the business. And then the third one is assume breach. And this is where the zero trust principle actually applies. And this is implementing security solutions and policies, pretending you have already been compromised and what security measures can be taken if compromised. And connecting from a particular network must not determine which services you can access. Access is only granted to services based on your identity, not from where you're connecting from or where you're connecting to. So for customers, ZTNA is a compelling offer, thanks in large part to how easy it is to transition away from your traditional VPN solution to a ZTNA remote access solution. And with ZTNA, the traditional VPN tunnel is replaced with ZTNA application access layer. This is also known as a FortiGate running FortiOS. So for customers who already have a FortiGate installed as their VPN gateway, this means that it's a super easy transition over to ZTNA because you don't need to actually replace that device. You just need to look at transitioning them from a traditional VPN, such as IPsec or SSL VPN, over to Zero Trust Network Access. And this means that we can resolve some of the limitations of traditional VPN remote access solutions, such as there only being one trust check on the initial establishment of a VPN, and also that access is granted to defined network segments where your firewall policies are dictating how traffic is allowed to enter your corporate network. All this, removing those limitations while bringing some of the ZTNA benefits, such as the zero trust principles that we just talked about. It provides granular access and security profiles on a per application basis, and it does that per session verification of your user and your device that user is connecting from. The Fortinet ZTNA solution utilizes at a minimum a FortiGate, which is obviously Fortinet's advanced next generation firewall, which I'm sure we're all familiar with at this point. FortiClient ZTNA agent, which is Fortinet's fabric agent that delivers protection compliance, and secure access in a single modular lightweight client. And then also FortiAuthenticator, which is Fortinet's powerful access management and single sign-on authentication solution. Now, some of the key advantages of Fortinet's ZTNA solution are that it leverages your existing FortiGate firewall, as we talked about before. It extends the security of your FortiGate to protect users wherever they are. ZTNA itself is not a licensed feature of FortiOS. It's just a part of the FortiGate, which means that if your customer already has FortiClient and they already have the ZTNA edition of FortiClient or higher, then there's no additional licenses that would need to transition from that VPN solution across to ZTNA. Simplified management and reporting thanks to the integration of Security Fabric. So if you've got something like FortiAnalyzer, you've got that ability to do all your logging and central analysis, even for ZTNA through that FortiAnalyzer. And you can do things like creating reports. And it's also relatively easy to transition, as we talked about, from VPN to ZTNA. Now, to go into and discuss how Fortinet's ZTNA solution actually works, I'll pass it across to Brendon to work through that with you.
Thanks, Kieran. That was a very good introduction to the ZTNA solution. So I'm going to take you through how it works. First of all, we have to understand the flow. So step one is that the user attempts to access an application that's hosted on your network. Now, what will then happen is FortiClient will then automatically create a tunnel to that application, well, to your FortiGate, and then allows access through to that application. The proxy will then verify that the user has the right level of access, and it will also check the posture of the device. If the check is successful, then access is granted. If it's not successful, then it's denied. The access proxy repeats these steps every time the user tries to access the application. So it is a dynamic tunnel. So behind the scenes, the first step is that we need to push out the access policy from FortiClient EMS server, so the endpoint management server, to those devices. And this then tells those devices how to get to the proxy server as well as the application. We then synchronize the ZTNA tags from those devices into the infrastructure. So those tags could be something like that the antivirus is on, and we'll see that in a future slide. And then we can use those tags to create access policies. We then create the tunnel and do the posture check between the services. And this tunnel can then proxy the HTTP and TCP traffic over the TLS connections, which then enables seamless access to the clients for these protected servers. And they could be in the data center, the private cloud, or the public cloud. It comes down to where you want to host them. This access can also be granted and checked through FortiAuthenticator as well, using the two-factor authentication tokens. So what are the components? So first off, we need a FortiGate. So the FortiGate controls the access proxies, it creates the authentication schemes, and it creates the ZTNA rules to then control the access to these servers. It also established the encrypted tunnel for which the endpoints connect to. So they're not connecting to the EMS server, they're connecting to the FortiGate. The EMS server also has a connection to the FortiClients, which then allows us to create the rules, create the servers. We can manage the endpoints. We can monitor the endpoints and monitor the applications that are on the endpoints and their vulnerabilities. We then report the tagging rules. We can then collate these tagging rules and report it to the FortiGate. And once they're on the FortiGate, we can then utilize them. The EMS server also communicates with the FortiClient, and there is always an encrypted tunnel between the client and the EMS server so that we can continually check that posture. The FortiClient will then create a tunnel to the FortiGate, as I mentioned before, and that's what that bottom line dictates down the bottom. We then also have the FortiAuthenticator, which communicates with the FortiGate only, and the FortiGate can use it as a radius server or a LDAP server. It's really up to you. And then we can use the two-factor authentication tokens, which is a Forti token, to basically, provide more security around your environment. So in FortiClient EMS, we can create a tagging rule. So these tagging rules we can define in many different ways. This one on the right-hand side that you can see in the screenshot, we've selected that it needs to be Windows 7 or Windows 10, and the antivirus software needs to be installed and running. But it could be a range of things. It could be a running process. It could be a network range. So, is the device on site? It could be the vulnerability state. Is there too many applications that are vulnerable or have a critical vulnerability on your website? Could also, sorry, not on your website, on your client. It could also be a user identity. It could be, any number of things. We can also just use regex strings as well. So be creative and create as many tags as you like. We can then have the tagging monitor, and the tagging monitor shows which clients are connected. So the endpoint name, it shows the user that's connected, the OS, the IP, and when it was tagged. Now these tags are constantly updated and constantly validated to basically give the FortiGate up-to-date information on which clients are connected, when they're connected, and how they're connected. This obviously is a posture check that happens in the background so that it can enable the access rules to basically allow the traffic if there's no vulnerabilities or if the antivirus is enabled. It comes down to how you define it. So in FortiClient, we can display these tags, and these tags are just on the information. Like if you click on the username, the T Smith in the top, it will show this page and you can see those zero trust tags. Now these tags can also be hidden. Some people don't like to give the end user visibility into the configuration of the FortiClient. Now, we can also create ZTNA rules on the FortiClient itself. This is good just for testing and development use. Saves you having to create it in EMS, push it out, and have the client receive it. What we can actually do as well is create it in EMS, and it's the same settings. We still have the destination name, we have the destination host, and the proxy gateway. So the name is just a name. The host, that's the IP address of the server, or it can also be DNS now as well, of the server that's on site that you're trying to connect to, or in the cloud, it's up to you. The proxy gateway is the public IP address, or in this case, an internal IP address of the FortiGate that is hosting that access proxy. We also include the port number so that obviously we know which port to connect to. Now we can enable encryption. Obviously we would always recommend encryption because then it masks the traffic to people that are trying to sniff it. We can also use browser, so an agentless session as well, which is the bottom tick box that we can also use with SAML login as well. So this is how we can configure a ZTNA server on the FortiGate. So there's a couple of steps on the FortiGate to configure the access proxy. Step one is to create the server. Now this is just like a virtual IP. We have a external interface, so it could be your WAN interface. In this case, it's port 3. We set the external IP address. If you're using the interface IP, it can just be 0.0.0.0, but it can also be any one of your public IPs that you have. And you also set your external port. So when we configure the ZTNA server on EMS, we put the port number in as a proxy address. That's just something to remember. We can then select the certificate. Now, these servers are hosted over a HTTPS tunnel using TLS, so we need to use a certificate to encrypt that traffic. If you use the default certificate on the FortiGate, that can also be imported into EMS and pushed out to the clients so that the clients trust that certificate. So once we've done the actual external component of this of the ZTNA server, we need to do the physical host, so the server on the inside of your network. Now, this one's set up for HTTPS, but it can be any TCP port. And we can match a URL as well. But then we also need to specify the IP address, the port number, and whether it's active. Now, you can have multiple servers in here, so it can do a little bit of load balancing, but by no stretch is it a enterprise load balancer. Now, we can also specify the authentication scheme. So do we want to use Radius? Do we want to use LDAP? It could be AD. We could use SAML as well. We can also use local groups on the FortiGate. So the FortiGate has user management tools. Or we can use FortiAuthenticator. Now, if we use FortiAuthenticator or the local groups on the FortiGate, we can also use FortiToken. So once we've created those things, we then need to create a access rule. Now, this is just like a firewall policy. We have our incoming interface, we have our source IP addresses that we want to match. Now, we can also choose to match the ZTNA tags that I mentioned before. Now, if we match the ZTNA tag, it now means that we are not advertising our service to the whole World Wide Web anymore. We're just advertising it to the FortiClients that are connected to our network. So this drastically reduces your attack surface. We then select the ZTNA server. We then the destination. Well, the destination in this case will be all because it matches the ZTNA server, just like you would with a virtual IP in your firewall policy. We then accept or deny the traffic based on that match. So for example, if you had a ZTNA tag that showed your clients were vulnerable, you could match that vulnerable tag and then deny the traffic. We can then apply our security profiles. So whether we want to do antivirus on that traffic, the web filter probably is not applicable in this sense, but it could be if you want to check the URLs that the client is going to. Same with application control. IPS, however, the IPS engine will pick up attacks. So if that machine is vulnerable, but we're not seeing it, they could try and attack the inside of your network. So IPS is very relevant in this situation. Same with the file filter. You know, we can select the files that we want to go across our network. And I would recommend doing deep inspection on this as well, because then we can actually see what's going on inside that connection. So then we can monitor which users and devices are connected. And this is just a traffic log, so it shows you the same information as the forward traffic, except it also has the users in it. And it shows you which real server they're connected to, which port number, and then which policy it matches. This can also be viewed in the CLI as well using the diag commands, which some of you should be familiar with. So some of the key features of ZTNA are SAML authentication. So we can use an external SAML authentication server like Azure AD, for instance, to authenticate the users and build that trust context before gaining access to the protective resource. Now, this would be done with FortiAuthenticator as the SAML proxy server. So the FortiGate monitors and changes the endpoint tags rapidly. Well, not rapidly. EMS pushes out the changes as soon as it's detected, and FortiClient routinely checks the device and reports on those changes. When a change is detected, the FortiGate changes the policy that it uses for that device. So if you had that block policy above it, when the client is vulnerable, it would then block that traffic. It's all about matching the tags that you have created. We can also use FQDNs, so full URLs that I mentioned before, so DNS names. So in this instance, they went to web.demo.com. Now that would be put in as the server in the EMS or the FortiClient configuration part. Now we can also use ZTNA Portal. So this is new in version 7.2 on the FortiGate. And what it allows it to do is automatically grab the ZTNA destinations from the FortiGates that the client is connected to. Now, this is done using the SSL VPN settings, and it basically just gives a JSON file to the client, and then the client can add that to its configurations. So when the user goes to those services, they then obviously access it with without knowing anything in the middle. It just creates that seamless experience for the client. And it also makes it easy for the administrator because you don't have to reconfigure EMS, with all the different servers and applications. The FortiGates can do it for you. So if you have FortiGates in a HA pair, there is no break in the communication if the HA failover occurs. And this is because the FortiGates can do session sync to then make sure that those sessions stay active when the HA failover occurs. So that's it for me. So I'm just going to hand back over to Kieran, and I hope you've enjoyed the session so far.
Thanks, Brendon. All right, so I'll give you a little bit of information about ordering, such as what the applicable devices are and the licenses that you should be looking at. So the first component we want to look at is the ZTNA Application Gateway, which of course is the FortiGate. Now, as we talked about, one of the great benefits of Fortinet's ZTNA solution is that there's no additional licensing to actually use the ZTNA solution. But when it comes to licensing, we would recommend that the customers sort of look at getting the FortiGuard Enterprise Bundle license when they're purchasing a FortiGate for ZTNA to make sure that you can use the security functionality such as IPS, antivirus, file filtering, and those services that we saw when Brendon was presenting. And it also gives you access to a whole range of additional services that are coming out with the new version of FortiOS 7.4. Now, another great benefit of Fortinet's ZTNA solution is that on the FortiGate, the exact same functionality is supported across all of their FortiGate models, meaning that you get the same user experience from a technology standpoint, regardless of if you buy a small or a large hardware appliance or deploy a FortiGate VM. The only difference is the capacity and the throughput that each model can handle. Now, generally, when you scope a FortiGate for ZTNA, you want to make sure that you pay attention to the SSL inspection and the threat protection throughput numbers. And then, of course, if you're deploying a physical FortiGate, you also want to make sure that you're looking at the physical interfaces on the hardware device to make sure that it can actually fit into the customer's requirements from a networking standpoint. Here's a list of the main SKUs for most of the FortiGates that we see deployed in the ZTNA solution. And then, of course, their appropriate FortiGuard Enterprise SKUs. Now, there's 12, 36, and 60-month license options on the FortiGuard Enterprise SKU as well if you need different varying license lengths for your customers. Now, the next component is the ZTNA agent, which is the FortiClient. Now, FortiClient can be provisioned on a per user or per endpoint basis and can be either managed from a cloud-based solution, which is Fortinet's SaaS offering, or an on-premise solution, depending on what the customer's requirements are. If you need additional managed service options, they are available to assist with your initial setup, user onboarding, upgrades, and other options, which is the managed ZTNA agent. And for a list of all the available options in their SKUs, please reach out and talk to our sales team or refer to the FortiClient data sheet or their FortiClient ordering guide. It has a whole list of information that goes through and explains all the different variations of FortiClient itself. But at a minimum, for FortiClient, you need at least the ZTNA agent edition. Now, the SKUs for that are pretty simple. If you want the per user license option, then that's the top row on the screen. If you want the per endpoint license, then that's the bottom one on the screen. And remember, this is the minimum requirements, which is ZTNA edition. If a customer wanted FortiClient to work as their EPP platform, then you would want to look at the EPP edition of FortiClient. And the great thing about FortiClient is the EPP edition includes all of the ZTNA licenses. So you can use the EPP edition to do ZTNA as well. And there's 12, 24, 36, 48, and 60-month license options available for all of these. So again, if you need more information specifically around exactly what SKUs you would need for your customer's deployment, just reach out to our sales team and we'll be able to assist you for that particular requirement. Now, FortiAuthenticator is available as a hardware appliance, virtual machine, public cloud, and FortiTrust Identity, which is essentially FortiAuthenticator Cloud. The hardware appliances and VMs are fully functioned offers, while the FortiTrust Identity is still being worked on for its radius compatibility. They're expected to have it fully feature-rich by Q3 2024, but right now it's in alignment for things like FSSO, single sign-on, multi-factor authentication, portals, and your certificate management. And now, of course, because FortiTrust Identity is a fully SaaS solution, don't be off-put by the fact that there's an NA against HA. It's just indicating that Fortinet is responsible for the uptime and back end of the service, so therefore you don't need to run 2 instances of FortiTrust Identity to create HA. Fortinet's responsible for the uptime and the back end of that solution for you, given that it's a SaaS solution. Now, we will have a lot more further information about FortiAuthenticator, how it ties into authentication piece for Zero Trust Access, and that'll be the third webinar and part of this 3-series solution. So if you want to come along and you want to learn a lot more about how Authenticator ties into this ZTNA solution, register and come along to that. Now, if you'd like a little bit more further information, of course, always reach out. We're always happy to help. But if you wanted to do a little bit of research on your own time, there's lots of really good information out there, such as solution briefs, marketing campaigns, and data sheets and all sorts of stuff. So the main resource is the Fortinet main website. And if you have access to the Fortinet partner portal, jump in the top right-hand side, you should have access to a thing called the asset library. If you go into the asset library and type in ZTNA, there's a lot of additional resources in there. That's really, really useful for ZTNA, and it helps you sort of break down and understand and be able to sell the ZTNA solution in really, really easy ways. Now, for anyone that's NSE 4 certified and above, you should have access to FortiDemo. And FortiDemo is essentially a free, full fabric environment that lets you spin up at leisure and fully customize out these lab environments. Now, they're automatically updated, fully licensed and accessible from anywhere, and this is all run by Fortinet. If you don't have access to this, then you can request access through the Fortinet Developer Network website, so fndn.fortinet.com. Now, if you need assistance with getting access to that, just reach out to our pre-sales team. We're more than happy to help you sort of get up and running with that. But definitely, if you have access to this and you want to get a lot more hands-on and really utilize ZTNA without actually deploying it to a customer site, definitely jump into this and have a look. But of course, if you would like us to do a demonstration for you, feel free to reach out to our pre-sales team and we're more than happy to do the demonstration for you as well. Now, I think we might hand it over to some questions. Brendon, I've got 2 main questions here. Is it okay if I read these out to you?
Yeah, I was going to read some out.
Sure, you go first. You go first.
That's okay. So one of the questions that we had was, do we have to use FortiAuthenticator, or is there a way we can use existing user setup investment in Azure AD and Microsoft Authenticator? So it's the solution with Azure AD involves using FortiAuthenticator as a SAML proxy. And this way we can actually streamline the authentication piece into Azure AD. And then whenever a user uses another SAML service, so you might be signing into another resource that requires that SAML authentication, the FortiAuthenticator caches that login, so it doesn't have to re-authenticate with Azure AD every time. I believe it can be done out of the FortiGate itself if you only have one FortiGate, but if you have multiple FortiGates, then FortiAuthenticator is definitely the way to go. But if you are integrating with Azure AD, you can use the Microsoft Authenticator as a two-factor auth token as well. And that's handled by Azure AD. It's not handled by the FortiAuthenticator. The Authenticator is just caching that authentication attempt. The other one that I wanted to touch on is the FortiGate 40F included in ZTNA. So ZTNA is included in every FortiGate model. So it doesn't matter what FortiGate you have, it's included. And you don't need an additional license for it. It is just baked into the FortiGate. Which question did you want to ask, Kieran?
I've got a really good question here. It's how does ZTNA and SASE fit together? Because they've heard that both solve essentially remote work issues. And I might try and see if I can tackle this before you have some insight here, Brendon.
Go for it.
ZTNA effectively allows you to do split tunnel trafficking of your remote teleworkers traffic, and you're routing only that traffic going into your data centers through the Fortinet, through your corporate solution, right? So this means, for example, if you had a client or remote teleworker utilizing, YouTube.com, you could send that traffic out just straight to YouTube services. But if you had them utilizing some sort of internal infrastructure, maybe you had like portal.demo.com was an internal piece of infrastructure, you could split traffic that those connections into your data center through ZTNA. And this means that a remote user's internet-bound traffic doesn't go through your enterprise VPN, very similar to your traditional VPN with split tunneling, and therefore you don't go through your enterprise security stack, leaving your user with little to no inline protection, but you're protecting your corporate traffic. So you're sending that through. Now, where SaaS comes into effect is it complements the ZTNA solution by providing a cloud-delivered security stack, essentially to try and inspect and secure the user's internet-bound traffic. So in the example that I gave before, where we were just sending general YouTube traffic straight to YouTube servers, any of that general internet traffic you could send to FortiSaaS. And then FortiSaaS is essentially a FortiGate running in the cloud infrastructure that will proxy that traffic for you, and you can apply your corporate security strategy on that FortiGate. That way, all the general internet traffic isn't going into your corporate network, it's going to Fortinet's SaaS solution, but you're still having that enterprise gateway in front of your general traffic, even though your remote users are outside of your corporate network.
Yeah, that's a good answer, Kieran. I guess one of the main differences, well, actually it's not even a difference. With FortiSASE, it actually, behind the scenes, it's actually a FortiGate and FortiClient EMS behind the SASE interface. So with that in mind, we can actually do most of the EMS features inside FortiSASE. So that includes ZTNA tunnels. So even if you are using FortiSASE, you can use the ZTNA proxy servers on the gates as you would with FortiClient EMS to provide that same solution. And as Kieran mentioned, the difference with FortiSASE though is the recommended deployment is to do a full tunnel back into FortiSASE so that you can then monitor and protect your endpoints using the web filter and application control and those sort of functionalities. No matter where they are located. So from there, we can then obviously break out the traffic going back local into your network, or you can use the ZTNA proxies to do the same thing. There's many different ways that you can achieve the same goals, and it just comes down to your use case.
Anyone that's interested in SASE, we will have an upcoming a couple of upcoming webinars next quarter, we will dive specifically into that solution as well. So bear with us, we're developing some content for you on that front.
Another question that's just come up, is there a way to influence the tagging from external solutions, i.e. via syslog or external integrations? The short answer is no, but it might be a bit more complicated. The FortiClient can only monitor what is on the actual machine that it is installed on. So if you have a way to influence what is on that machine, like for example, it could be a text file. So if you can check the presence of it, like FortiClient can check the presence of a text file. So if you can generate that text file on the endpoint, well then you can then generate a tag based on that. So the short answer is no, it cannot be direct into EMS to influence it. But if you can do something on the endpoint to trigger a tag, then yes.
Perfect. With that, if there's any additional questions that you guys have, either past this event or anything, just please feel free to reach out to us at pre-sales. Otherwise, to help you get onto the road to success, I've sort of put together some next 5 steps for you to take. So if you haven't done so already, I'd highly recommend you register for our upcoming ZTNA webinars. The next one is on internal network segmentation and using ZTNA to solve that. And then also the third one is the identity authentication using FortiAuthentication. FortiAuthenticator. Next step would be to reach out to your account manager or to our pre-sales team to arrange further discussions. We can do sales type discussions or pre-sales and technical discussions. Please let us know what you need. We're happy to help. Run an internal demo and gain first-hand experience with developing ZTNA tags, the rules, and the access rights, because that's what you need to get up and running with Zero Trust Network Access. Then run a demo for your prospective customers, because the demo helps to highlight how ZTNA provides a secure and really convenient teleworker solution. Again, when ZTNA is done and installed properly and is up and running, it's completely seamless to your teleworkers. It's a really brilliant solution. No longer do they have to connect to a VPN and make sure that that's connected before they can start utilizing the services. It's all done on a session-based process in the background for them automatically. It's absolutely brilliant. And then the 5th step is, once you understand the solution completely, develop and sell a converged Fortinet security platform designed to work for your customers. Thank you so much for attending. Again, if you have any questions, please feel free to reach out at any time to us here at presales@wavelink.com. With that, I will hand across to Adriana to send us off.
Thank you, Kieran and Brendon, for that very informative webinar. As Kieran mentioned, part 2 of this 3-part series will be on Wednesday, the 31st of May. So to register and for more information, please visit our website, wavelink.com.au. For any questions, reach out to the team. Otherwise, thank you again for joining us this morning. Thank you, Kieran and Brendon. Have a great day and see you all on the 31st.
Thank you, everyone.
Thanks, everyone. Have a great day.